given a charged conductor with charge Q and potential V, keeping the charge on it same, if we reduce its potential, the capacity of the conductor gets capacity of the conductor gets increased. Yes or no? I have a charged object. Q coulombs of charge is there on that object, because of which the potential of that object has become V. If we can reduce the potential of that object without changing the charge on it, the denominator is reduced. In C is equal to Q by V. If you reduce V, keeping Q same, we say that its capacity gets increased. Such an arrangement gives a two-terminal network component called as capacitor. Maybe lectures on physics by Feynman. Long back. Check it once. I'll prove it also, don't worry. No extra work need to be done. By keeping the charge on the conductor same, we can reduce the potential of it. That when I studied actually, it was like this. Point number 1. Check whether you accept or not, whether it is clear or not. If the potential at a point due to Q1 is V1, Q2 is V2, carefully. If Q1 is positive, V1 is positive. If Q1 is negative, V1 is negative. You agree this? At the same point, if the potential due to a charge Q1 somewhere is V1, Q2 at some other point is V2, and Qn is Vn, when all the charges are present, if all the charges are simultaneously present, the potential at that point is sigma summation Bi. That's what we told, right? Integration we did. Means what? That is summation under limit. Potential like force and electric field intensity, which follow the principle of superposition because of Q1, it is vector 1, Q2 vector 2, Q1, Q2, so both are there, it is vector sum, I told you. Here, it is a scalar sum with their signs. It is actually called as superposition principle for potential. Charging is a process. Carefully. When you basically want to charge an object, we should either remove electrons from it or add electrons to it. There will be an agent to remove the charge or add. Suppose electrons are removed from this to make it a positive charge. Those removed electrons, if they are added to another conductor, one case is what? Electrons removed, first case. Case 1 is electrons removed are given to earth by the agent. We can always do that. Next case is what? This can be done in two different ways, I'll tell you. Next case is electrons removed, whichever the electron the agent removes is added to another conductor. Then this is the practical system for us. Nowhere the circuit is connected directly to the earth. There is a common potential point. Total charge in the system remains the same. If Q coulombs of charge is created on one object, minus Q coulombs of the charge is created by the other object. Listen carefully, one more thing. Suppose you should tell me the procedure name. There is a positively charged object where it is charged by supplying the electrons, throwing the electrons into ground, and then removing it. Agent is not there. This is positively charged. If I keep an object, electrical object, in its vicinity, what will happen? Negative charge gets polarized onto the surface nearer to the positive charge, and the positive charge gets polarized onto the surface away from the charge. Because it is just hanging. Total charge on it should be 0. Negative charge moves towards the positive charge. Positive charge moves away. Now, if you connect this to earth, you know what happens? This positive charge will go away. To the earth. But this negative charge is created. What is the procedure called as? What is this procedure called as? Charging the object by induction. The positive charge on the first conductor induces negative charge on the surface nearer to it, positive charge from on the surface away from it. If you connect it to the earth, even if you remove that particular connection now, that negative charge will stay. This is called as charging by induction. Whether the negative charge on the conductor kept in its vicinity is created by induction, or all the electrons removed from one conductor are added to the other charge. Two conductors having equal and opposite charges are created. In the absence of the other conductor, the positively charged object is there at some potential V, called as V plus. When the negative charge comes onto the other conductor, at any point on the surface of the first conductor, there will be V minus also. But definitely because it is away from it, the negative charge on the first conductor, negative potential at any point on the first conductor, because of the negative charge, will be smaller in magnitude than the positive potential because of the positive charge on it. The concept is the arrangement, increasing the capacity of the conductor, the arrangement using which the capacity of a charged conductor is increased by keeping an earthed conductor in its vicinity is called as capacitor. That arrangement is called as capacitor. Now, you see that initially V plus Q by V plus is equal to C. Once I have the other charged conductor, keeping the charge Q same, it becomes Q by V plus minus V minus, because charge potential because of negative charge at any point is negative. Negative charge is negative because of which this total potential gets reduced, and this yields C. And such an arrangement is called as capacitor. Now, because it is, the other thing is what? Zero potential point. Now the field will be there from positive charge to negative charge. We need to see the structure. Starting at zero potential, now so every capacitor such an arrangement is capacitor. I told you, right? Somewhere I wrote also. Called as capacitor. Every capacitor consists of basic capacitor, two conductors separated by a dielectric medium. Dielectric is non-conducting medium. In a capacitor, if the charge on one conductor is plus Q, charge on the other will always be minus Q, in magnitude same, because electrons are removed from one conductor in the system and put onto the other conductor, because of which first one becomes positively charged, second one becomes negatively charged. It's same, because number of electrons removed from this is equal to number of electrons added to this, Ne, plus for the first conductor, minus for the other conductor. right? With charge Q on each conductor, Q1 minus Q, with the amount of charge, with the magnitude of charge on each conductor is Q. If the potential difference between them is V. Hey, is the potential difference between them? Is the potential difference between them be the potential of the positively charged object? Potential difference between them is nothing but potential of the conductor with plus Q. Is V. Do you agree this? Potential difference between them is what? See here. Integral E bar dot dl bar in this figure. Again, the field is what? From minus to plus. Integral minus E bar dot dl bar. Is the potential difference between these two conductors. Because this conductor is supposed to be earthed. It is supposed to be there at zero potential. With this at zero potential, I told you, if it is a single charge, zero potential point is there at infinity. If I connect a conductor to the earth, that conductor is at zero potential because anything that is connected to earth will go to zero potential. That is how we save ourselves from the shock, accidental shock by motors or the heavy power equipment where there can be a leakage of power at the surface. When you touch it, you will experience the shock because of it. We will basically, power equipment will have 3-pin plug in which one of it is earth, and that earth is connected to the body of it. Because the earth is connected to the body, the third terminal, the body of it will always be in zero potential. Standing on the ground, if we touch it, there is no potential difference because of which we will not experience the shock. Because a negatively charged object is supposed to be there at zero potential, taken as reference. This potential difference itself will become the potential of the positively charged conductor. I think you understood this. Q. The capacitance of such a capacitor is Q by V.